Hello friends, welcome to Techmaima YouTube channel. In this video, I'm going to explain using opencv how we can read an image and how we can detect a face in an image. That's what we are going to see. So let's get into the video. To use opencv, first of all, you need to install opencv in your machine because it's a third-party library. It is so powerful library. Okay, this is used for image detection, motion detection, and then for many other purposes we use opencv. To install it, here is the command. So pip space install opencv-python. So you can copy this and you can put down in your cmd command prompt, else you can go to python and here is terminal. You can use the same command here, so it will install. If it is already installed, it will tell requirement already satisfied. Since I already installed, for me it says requirement already satisfied. Okay, then you have to import cv2. cv stands for computer vision. Okay, and in opencv there is like two different terms. Whenever you're reading an image, either you can read in a color format or you can read in a grayscale format. Okay, so to get it in grayscale format you have to use 0, and to get it in color format you have to use 1. Okay, so now I'm going to read an image. For that I'm using the method imread, cv2.imread logo.png is my image. Okay, so here I'm going to give 0 so that it can take in grayscale color. And then if you check type of an image, okay, let me make everything as comment. So you can check the type of image. Okay, if you run this is different. I need to run opencv. Yeah, see, it is class numpy nd array. Okay, this is the type of an image. And then you can check the dimension. In numpy I would have told you can use ndim to check the dimension, right? Same thing you can use here. See, it's a two-dimensional array, because how it will read an image means it will be converted into array format. So whatever image it takes, it will get into the pixels, and then those values will be converted into array format. That is the reason we use numpy array to read and access these images. Okay, so if you check the dimension, the array format will be two-dimensional array. And then now I'm going to print the image. What I read using this, I'm going to print the image. If I run this, see, when I click on print image, this is the array structure that I'm getting. This is the array structure that I'm getting. See, since I used grayscale, this is the format. If you use one, that is RGB, like normally it will take red, green, blue, this colored format only. Okay, so if I give 1 and if I run this code, it will be this array values are different. See, look at this. See, this is totally different. So this is how you can print an image, I mean to check the array structure. Okay, so there is one more comment which is image.shape. You can check the shape of an image. If you run this, see, this is the structure 1080 comma 3. And then yeah, shape I already explained you in the previous video also, so I believe what it gives. And then now I'm going to show you the image. I read already, I have shown you a few more comments. Now I'm going to show the image. For that I'm using cv2.imshow. so this is the name. It's not the image name which you are supposed to give. You can give anything, and then here I'm calling the image. Okay, so either I can type it as image. Okay, so if I run this, have you noticed one screen came and it went in a second, not even a second? See, right? So why? Because it is reading the image, but since we have not given any wait time here, it's just going in fraction of seconds. For that, to avoid that, you have to use this cv2.waitkey. And here why I'm giving 0 means 0 will give you infinite wait time. So if you give 1, it will go in 1 second. Okay, say I have given 1. If I run this, See, it's gone in 1 second. I'm changing it to 100. Look at this. See, now you can see a little more extension. Like I have given 1000 now. See, now you can see. Then it will go in 1000 seconds. Right. So that's the reason I have given 0. When I give 0, it will be available here only. It won't go. It's like infinite. Okay. This is the purpose of using wait key. So now I have closed that image, but by default, like you have to make sure, because I'm not using any Photoshop or photo viewer to view this image. I'm using viewing this image using Python, right? To ensure that everything is closed, I'm calling this method cv2.destroyallwindows. What if I'm opening 4 different windows? Like it will destroy all the windows. For that purpose only, this one I'm using. Okay, so if I'm running this again, see, I got the image as I expected. So I closed it for now. So this is how you can read an image using opencv. Okay, so 2 different important methods I used. imread to read the image. One is for RGB red, green, blue color format. See, now I changed it to 0. If I run this, look at this, you can see the gray scaled color. It's a gray color, right? Black and white is what? Gray scaled color. Okay. So for any image, you can give any image and you can read the image. For here, to show the image, you can use imshow and the name what you wanted to give, and you can call the image here. Okay. So it's very mandatory to use wait key. If you don't use, the image will appear and it will go not even a second. 1 second it will wait. It will go just like that. Okay. So this is how you can read an image. Now I'm gonna explain you how to detect a face in an image. I have an image that I need to detect a face. Okay. So here I have another file called as face detection.py. This I created few minutes ago. Again, you have to import cv2. So I'm going to read an image. I told you how to read an image. So my image name is pic.jpeg. I have not given whether I wanted to read in RGB or grayscale. If you want, you can give. If you want, I'm going to give 1 low. So it will be red, green, blue format, RGB format. Okay. So this is a different line you might see here. What does this means? Cascade classifier. This you need to create. Why? Because here you can see a link. This is a default link which is available. It comes with a structure. So face means in which structure it should look. So if we are reading an image, you will be reading in a rectangle shape, right? So this all are predefined, okay, in XML format. So this is the link. Even if you Google it, it will come for you. So this I just took it and I pasted the link in the cascade classifier. So this is under cv2. So this part you need to remember. While creating cascade classifier object, you have to give the link where the face structure is already defined. It's a XML file. Okay. And now you will not understand, this is for human face. What if you are going to read a face of a cow or face of an animal, monkey? So in that situation, this XML file varies. That face structure differs, right? So there it varies. And in many places, the classes are predefined. So in video motion detection, if you are going to detect all the objects which is available in front of you, for that you should have predefined classes. If it, I have a mouse in front of me right next to my system. If you are showing the camera right next to your mouse, it will detect, okay, it's a mouse, kind of. Such a way, for that purpose only we use cascade classifier object. Okay, so it's done. I have given the link. This link you can Google it. You will get it from there easily. And then else I will give in the description also. You can copy this. And then now I'm showing you reading the image in gray format. Okay, so gray image equal to cv2.cvt color image comma cv2 color. And this you can, when you are using PyCharm, by default it will give you the options. When you type cv2, what might be the next, what is the next option? Like from here you can choose. Okay, I'm typing color. See, blue, green, red to gray is what I'm gonna convert. Okay, I have given it's a structure to convert it to gray format. and then so search for the coordinate of image. So here the image size, the less the image size, the less the accuracy. Okay, like if you have a very big image and you wanted to find out the face out of that image, it's pretty difficult, right? So the moment when image size reduces, look at this. Okay, this is an image I have, so I'm reducing the size like this. Now I have an image like this. Here I can detect the face very easily, right? That is the concept here. So to do that only we use this. So here you can see face equal to cascade, detect multiscale, comma gray image. Here I have converted as gray image. That is what coming here. Like look at this gray image. You can see here. So this is new thing. Scale factor is 1.05, and then minimum neighbors is 3 I have given. So what is scale factor means? When you read an image, in that face this rectangle shape will come, right? So if based on the image size, if I'm giving 1.05, based on that only it will choose. I will tell you the real-time example at the end of the video, like why we use scale factor. Okay, and then detect multiscale will help you to find the rectangle coordinates. Okay, so this is the rectangle shape, right? To find the rectangle coordinates only we use detect multiscale. Okay, so I'm gonna print face now. Just a minute. Yeah, so print face. I'm going to iterate over face. Okay, for ABCD, like for in rectangle 4 different corners will be there, so of that I'm considering for ABCD in face. Image equal to cv2 dot rectangle method I'm using here. Image comma a comma b, so x comma y, this is what a comma b comma a plus c, this one left side angle. Okay, so this one x comma y, and then like that is what a plus c, and then b plus d. Okay, a plus c and b plus d, this is how it will be calculated. And if you look at this one 0, 255, 0, this is red, green, blue, like the color format. Okay, so since I have given the full color for green, this box will appear in green color, and this is the width. Okay, so now I'm going to print the image. If you want, you can resize the image. This is the code for resizing. In the like few minutes back I told you how to resize an image. I'm not resizing because I know the image format size itself very less already. If you want, you can try that, else that is not an issue. Okay, so imshow image name that I'm giving randomly, and then comma img, and wait key I have given, and destroy all the windows. Like if I open, a new pop-up will be opened, so that I need to destroy. For that I'm using scale factor. I will explain you now. Okay, so let me run this first. Face detection I'm going to run now. See the beautiful image what we have right now. It's famous actress Alia Bhatt. So look at this, how beautifully it is detecting the face from this picture. Okay, so the size, what you can see here, this thick line, so this is what the width that I have given. Okay, and then if you look at this 4 corners, this is what detect multiscale does to identify this. So scale factor, see, now you look at this structure properly. Now I'm going to change the scale factor. Okay, I close this image. I'm going to give 15, delete 15 or 25. Okay, if I run this, see, it didn't detect anything. I'm going to give 15. Okay, if I run this, see, I believe now you can understand what is the purpose of scale factor. It will scale the size. Okay, wait one more minute. Like here, the important thing, you can give, you cannot give less than 1. Okay, it should be 1 or more than 1. 1.10. I already tried this. 1.01 I'm giving. Okay, if I run this, see, it detects the image. So it varies, like what if you have 10 pictures, the system itself will be confused. It will give you all the possible angles. See, I have only one image. These all are the four corners of an image. For A, B, C, D, these all are the four corners. That is what we can see in the image also. There are four different corners. Okay. So this is how the scale factor will work. And in many times you have to change the scale factor as per the image. This image is very clear. It is looking straight forward to us. But if you have an image which is looking on the left side or right side, during this time scale factor you have to change to get the proper detection of your face that you're expecting. Okay, so that is the purpose we use scale factor. Like if you want, I can change once again 1.04 I have given. I run this. Yeah, it's working. If I give 1.08, this is also working. So there is a limit, and as I mentioned here, the lesser the image size, the more accuracy you will get. Okay, whatever the image size bigger you have, that is the purpose of using the reuse method here. Okay, so what we did, we have imported CV2 and then I read an image in red, green, blue, RGB format, and I'm using cascade classifier object. So here the face structure is already defined in this XML link which is available in Google, and then I'm reading it in a gray format, and then I'm detecting multiscale. Okay, the cascade.detect multiscale gray image. So scale factor and minimum neighbors I have given, and then I'm iterating over it. Okay, and then now I'm going to read the image. This is what I have done. So now we have successfully detected the face. Okay, so that's all about face detection using opencv. If you have any doubts, please put down in the comment section. I'm happy to reply back to you. We'll see you in the next video about video motion detection using opencv. Stay tuned. Bye bye.